Hello everyone. Hi guys. Welcome to our session today, ML Developer Day. So let me just go back to the previous banner. So welcome all of you guys. I hope you guys are staying safe out there amidst the situation that's occurring right now. And also thank you guys very much for gracing us with your afternoon on the weekend to join us today with our awesome speakers and as well as the topics that they have for all of you guys today. So without further ado, let me just run through a few things that just to get you guys started before we jump into the sessions. Okay, so before we start, this is a joint collaboration between GDG Singapore as well as GDG Cloud Singapore. So if you guys have attended like the Chrome Dev Summit extended last week, so that session was organized by GDG Singapore. And then in the midst of last week as well, we had a webinar from GDG Cloud Singapore, which explored about GK-related features. So today, we have come together as part of this collaboration to bring to you this ML event today. Okay, so welcome to all the different communities around the region, around the world who have tuned in today and grace us with your presence for this event. Yay! So very much like to welcome you guys in, and I hope you guys are able to tune in and learn something from today's event as well. And also for people of different nationalities, different places, if you guys have any questions, the YouTube comments are, if you're tuning in from YouTube, the live comments over there, you can ask your questions at any time. Our speakers will be able to see those comments and answer them in time. Yeah, and don't forget to like and subscribe to this live stream as well as the YouTube channel, and share it with your friends if they're interested in ML, and you can tell them, hey, there's this cool live stream that's going on right now. And yeah, so GTG Singapore is looking for volunteers. We're looking for talents in different fields to make our community events better. For example, you can see that we are looking for designer to help with creating artworks, such as the awesome one you saw at the earlier banner, in the earlier part of these slides. And also, we're also looking for talents who will help head our Firebase as well as Flutter, as part of serving as a project manager. So manage these related activities in terms of meetups, code labs, and also taking charge of the track within DevFest later this year. Okay, so if you're interested, by the way, my name is not Julius. My name is Wei Yuan. So, but if you're interested, you can ping either Julius or any of the other organizers of GDG Singapore via that email you see in the screen. So singaporegdg@gmail.com. Okay, and so just a list of all the upcoming events within the next few weeks or even in the next month. In the next week alone, we have Android 11 Chat. So May 16th, this is within the midst of next week. Or in fact, no, it's next Saturday. Yeah. Okay, so the details regarding the timing will be posted later on within the Facebook group as well as the meetup page as well for GDG Singapore. And also from as part of GDG Cloud Singapore, we're also going to be hosting our third webinar following our previous second webinar. And the topic is going to be revolving around BigQuery. So again, we will be releasing more details on the exact date as well as the time as the within the next week or so. Okay, and Android Day as well. More info to come, so this should come within the next few months. So again, look out for GDG Singapore's Facebook group meetup page for more information. And as I mentioned earlier on, we had our Chrome Dev Summit extended last Saturday. But the thing is this, there's a huge bunch of topics that can be covered regarding to Chrome as well as that ecosystem. So we still have many other exciting speakers as well as their topics in store. And look out for this event. This should be within the month of June. Okay, and also another event. So this is Introduction to Google Marketing Platform. And this will also be in the same format to most of our events over here, hosted on YouTube Live. So again, watch out for those events, the timing itself, and when they will be published within the Facebook and Meetup pages. And so Firebase event, upcoming event as well, sometime within the next month or so. And one of the most important things, so if you're interested in looking into contributing back to the community, in terms of topics that you want to speak to the community, sharing your experience that you gain at work, and you want to let people know, how can I build this, for example, this Firebase application better? How can I use Firebase cloud functions? We are always looking for people in this different fields to come along and share with us their thoughts or learnings across the years, back to the community. So if you're interested, do share with us your profiles and your topics within this link over here, GDG's SG CFP. Okay, and most importantly, so I keep mentioning about the meetup page, Facebook page, because this is where you'll get all the juicy information on all the events that are coming up. So as you can see over here on the screen, we have our Facebook group, our meetup page, as well as the YouTube channel, which you are on right now. And okay, so without further ado, let's move on to the bulk of today's event. What you guys have been waiting for, the talks and the speakers. Okay, so today, just to introduce the lineup of speakers, so we have three very exciting speakers as well as our topics today. We have Armel, who's going to be starting off with the day's machine learning. That's his topic, and following on by Guan, who's going to be talking about building a chatbot, as well as the intrinsics of that topic itself. And lastly, we have Archana, who will be talking about neural networks as well as using TensorFlow. Okay, so without further ado, let's invite our first speaker. So let me introduce him briefly before we hand over the floor to him. Okay, give me one moment here. Okay, so just to introduce on Armel. So Armel is a junior data scientist, and he's also a certified ML as well as TensorFlow on Google Cloud Platform, certified big data, engineering data on GCP. He's passionate about new technologies like TensorFlow, and he's the TFUG Abidjan lead and the co-organizer of GDG Cocody. Okay, so let's welcome him on today's topic that he has for us, the day's machine learning. Okay, we have some short technical difficulty, so let's give him some time here. Hi, Armel.
Hi everyone. How are
Hi.
you?
Doing good.
Yeah. Hello. I am. My name is Armel Yara, and I come from Cote d'Ivoire, and I am DDG's co-organizer, Cocody, and TensorFlow user group lead. And today I want to show you our use machine learning in on this world, and what is the opportunity machine learning brings us. So we can start. Okay. Okay. Let's minute. I share my screen. Yeah. 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 So before I want to thank grateful GDG's Singami to give me so machine learning and opportunities. So when I'm presenting today, I want to talking with this machine learning. Uh, what I mean by with this machine learning. So I mean by with this machine learning that we live in machine learning era. ML is topical machine learning. So I want to call is ML machine learning in is topical is everywhere. So in my suite of presentation, I will presentation our machine learning is everywhere. Today we see a lot conference event community talking about that. Uh, so some summit event talking about machine learning. So what is really machine learning for the people? What is machine learning really? In fact, what the people call artificial intelligence is actually machine learning. So for data scientists, for computer science, and for students in computer science, say that's machine learning. But other people say that's artificial intelligence. So machine learning is data processing from statistic tools to explore data. Uh, to explore data to solve specific problems at the current time. When we letting machine learning learn with computation rather than giving it. So they are in my screen. I hope you see my screen. You can see artificial intelligence uh, in the around artificial intelligence. After you can in machine learning you have three kind to learn machine learning: supervised learning, unsupervised learning, reinforcement supervised learning. I will see presentation. You can see every case: supervised learning, unsupervised learning, and reinforcement supervising learning. So now I want to show you how machine learning is everywhere. So uh, in my introduction, I said that machine learning is everywhere. But how? Presently, with machine learning, we can predict cancer. So some computer virus and spam are stopped by machine learning. We can do sentiment analysis with the picture. You can see in my screen um, the the people, the face people are recognized by by computer. In the text, when to post in Twitter or Facebook, you can with machine learning detect your sentiment. So if you have angry, you have not satisfied. Okay. In the marketing, you know if customer is satisfied. You can take to improve our product, to to build a good recommendation in entertainment or publicity for customers. You can do financial prediction. You can do financial prediction. You can also submit recommendation to user like on Netflix. So you can see when you see your Netflix, you can see recommendation. So 80% match, 580 percent match also. And research some products on Google. You search the when you search the keywords in the Google Chrome. So machine learning can trying to detect your keywords and to bring you some results about your keywords. Is the machine learning using it today, and it's very important today to know that machine learning can um detect is very important in medical research, because with machine learning you can detect some disease before you can catch up. So it's very important to today to take machine learning in medical researches. So you can see in my screen also the car without the driver is important, because you can see the car can move in from point A to go point B without a driver. Is a very important. Why you use machine learning? Uh, it's very important to use machine learning. Uh, every day, human are facing many problems, like to increase business, to eradicate cancer, to solve many disease like coronavirus. Uh, Today you use AI to detect coronavirus in the person, to find a way to go at work, uh, to learn other languages, also to classify image. So there are many problems you can resolve with use machine learning. It's very important. You can see in my first problem kind type problem. So why you use machine learning? When I start my presentation, I show you the different uh, the different parts of intelligence, artificial intelligence. So they are machine learning and deep learning. Today my topic is machine learning. Machine learning, there are three methods to run: supervisor learning, unsupervised learning, and reinforcement. What is supervisor learning? Supervisor learning, there are two problems. When uh, you are you have a problem to solve by machine learning, it's important to know the data type. The data type. The problem is classification or regression. If your problem is classification, you can use SVN, logistic regression, Kinen, naive Bayes decision trees. If your problem is order in regression, you can you can use right lasso regression, linear regression, polynomial regression. So all that is the function you use to can solve problem in machine learning. Unsupervised learning, you can use clustering or pattern search. So you can see clustering in clustering you can see some function: k-means, dbs scan, agglomerative, mean shift, fuzzy means. In pattern search you can see eclat, a priori, fpa graph. In reinforcement, uh, In reinforcement learning, you can see generic algorithm, A3C, SASA, Q-learning, deep Q-learning. So when you can back in classification, so in supervised learning is when you have data with labels. Is different to unsupervised learning. In supervised learning, data is without labels. In supervised learning, data have label, and you can use classification. You can use classification when is uh, your data is not continuous numbers, right? So it can the data can take uh, uh, two numbers also. So no or yes, zero or one is dependent. I mean, regression, you can take multiple number between 1 and 2. You but the data can take one point 19, 1.15, 2.5, etc. So in function your data, you can take the classification or regression. Is the same in supervised learning. In supervised learning, the data don't take the label, so you can use clustering or pattern search. It depends of the data type. It's the same in reinforcement learning. After I can I can show you our stats with machine learning. So because today machine learning is very important in some domain in the world, is for data scientists, for financial, for medicine, for teachers in education. And our start with ML. So to start with ML, you can have some skills in mathematicals, probability, statistic tools. Is very important to start with ML, because when I start my introduction, I say that machine learning is a statistical tools uh, that you can use it to solve many problems. So if you have if you have a skills in mathematical, is very important. But if you have not skills in mathematical, you are beginners, you you don't know what is machine learning, you can start with Kaggle. Kaggle is a platform for data scientists to solve. Yeah, Kaggle, yeah, have many data sets, many courses to start in machine learning. You can use Google developers code labs. Google developer code labs have some laboratory to start in machine learning. Uh, you can know you must learn Python. Python is the principal language. Well, for me is the principal language to build the model on in machine learning. With you must learning Python. You must learning Python is very important to start in machine learning. After they are collab. Collab is a platform from Google to train ML. some ML and model ML model. You can see also the courses in machine learning on TensorFlow. You use Colab to train model, to convert the ML model in a TensorFlow Lite, on TensorFlow Lite to deploy it on the mobile. So it's very important. Colab, you must use Colab to train machine learning model. Is very important. Also, you can use Jupyter. Jupyter is a notebook to write Python codes, programming codes in Python. Is very is useful to build also model with machine learning model. So after this presentation, I want uh, to invite you to join a community nearest us in Singapore or Abidjan, Ivory Coast, to start your journey in machine learning. If you are very passionate in machine learning, you want to learn machine learning, I join community online, join a community like GGG's, DSC, or um, TensorFlow user group. There are also developer Facebook cycle with a use to also machine learning model. I use a TensorFlow to build some models and to introduce the beginner in the machine learning domains is very important. So near you, and why not to start your journey in machine learning? Also, I have this is the end of my presentation. I hope you are you appreciate my presentation, and if you have any question from me or any question on machine learning, I am. Thank you.
Okay, I think there's a question for Armel. This is Julius, by the way, who's kind of coming out in the background. Well, yeah, I think you're muted, but let me read the question for Armel.
My bad, my bad.
No
It's,
worries, no
sorry,
worries.
sorry, sorry.
Okay, I think there's a question for Iyer. This is Julius.
Yes, so Armel, the question is, you mentioned that on ML being used in entertainment, transportation, media, healthcare. What do you think will be the next frontier to harness ML?
I see the question. I see one question. Hi. Uh,
Question is, ML being used in entertainment, transportation, healthcare. What do you think will be the next frontier to harness ML?
um, let me to retrieve my.
Okay, I think we have some technical difficulties over here. So, okay, I hope my audio is coming through this time. Apologies about that. Okay, I think let's wait for a bit. I think Armel is restarting his stream. Uh, okay, since it looks like it might be taking a while for this for me to be rejoining a stream. So, let's jump on to the next session first. So later we'll come back to Armel again once he rejoined the stream. So, let me continue with our next speaker. Okay, so let's move on to our next speaker. So for next up, we have Guan, who is a GDE, Google Developer Expert in ML. He has worked on data science projects for the insurance industry at Swiss Re NLP and machine learning projects at Lenovo Big Data Lab. So as machine vision projects at Hong Kong Applied Science and Technology Research Institute and system development at ASM. So let's welcome Guan on his topic, building a Chinese chatbot, data algorithms and tools.
Hi everyone, can you hear me?
Yes, we can hear you.
Great. This is Guan. So I'm a senior data scientist working for Swiss Re. I actually just recently relocated from Hong Kong to Singapore. And frankly, I've been working from home since the start of this year because of this coronavirus lockdown. But that's good because you spend more time with your family and you can actually be more focused on a bit of development work. So today my topic is about building a Chinese chatbot. It's data, algorithms, and tools, but basically I will try to cover a bit of the related topics in NLP. This is the agenda. So I will first talk about what is NLP, what is tasks, and then I will cover a bit of chatbot for vertical domains, and at last I will show you a tool that we built. Maybe if we have time, I can demo a bit. I put a picture of a cake here just to show you that chatbot is just like this cake, and all the different algorithms and tasks are just like the different ingredients of that cake. And because of the development, the more advanced development of all that algorithms, now we can actually deliver a very delicious cake here. For today's talk, I will focus a bit on the Chinese version of this cake, but of course, you know that the most advanced cake would be the English NLP there. So let's jump right into it. The first one, NLP tasks and algorithms. So before I really talk about what NLP tasks is, I would like to bring up this very important concept of word embedding. From my point of view, the development of word embedding or the invention of word embedding is really a separation, a milestone of NLP research, natural language processing research. Because before the word embedding was invented, the NLP area is more ruled by the linguistics, meaning that they're looking into the language characteristics, they're writing linguistic rules to actually solve the NLP tasks. But then with the word embedding, we totally jump into the area of deep learning and using word embedding to do a lot of fancy things. So what is a word embedding? A word embedding you can consider is a vector that each word can have, and you can see in this space, each of the word will occupy a point in this space. The amazing thing about word embedding is that although it's just a vector, it actually contains a semantic meaning of that word. So what you can do is that you can, if consider each word is a vector, what you can do is you can do an equation like him minus man plus woman, and that vector, what you get at last, is actually correct. So this is the amazing part of word embedding. So I tried it on Chinese, and you can see that this is I trained on a certain area of documents, and you can see that if I put this is Guan, I put input Guan, and I find the most similar words. You will see that it's all about Guans. So traditionally, what you can do is you can only do the character similarity matching, right? You can only see, okay, all the words with a Guan in it will be related. But as you can see, you also find knives, you also find different types of weapons here. And same for here, that you search for hammer and you find all kinds of hammers and knives in there. So that's the amazing thing of word embedding, that it contains the semantic meaning of that word in that magic vector. And the way you train algorithm to get such a kind of vector is through this shallow neural network. I'm sure you're gonna find a lot of related materials on the internet. So with that word embedding, from my point of view, the overview of NLP tasks can be actually divided into these four main categories. The first one is that you're starting from a category and you're generating a sequence. Example of this category is like text generation. You gave a topic, and the algorithm will automatically generate you a text. Or you input an image, and the algorithm will automatically tell you the caption or the description of that image. The second one would be sequence to category. Example would be text classification. So you input a piece of news, it will tell you it's about sport or it's about politics or other things. Or sentiment analysis, where you just input a news and will or a comment. If you buy from Shopee, it will give you, okay, that comment is positive or negative. And one important thing I will cover later is about relational extraction. So you input a sentence with two entities, and you try to find what's the relationship between that two entities. The third category would be from sequence to sequence and is synchronized. Synchronized means that while you're inputting that sequence, it will in real time getting you that output sequence with each part of the input that you have input into the system. Some examples are tokenization, part of speech tagging, and semantic role labeling. And one important example is entity recognition, where you input a sentence or article and you try to extract the important entities out of it. As you can see, here is an example that we're using Spacey package to extract the important entities like the corporation names, organization names, or person names. The last one is still sequence to sequence, but from an asynchronized way, meaning that you input a sequence and the system will wait until you input the whole sentence before it gets you the output sequence. So some examples will be like machine translation, text summarization. Text summarization basically will input an article, it will output a small paragraph or short sentence that try to summarize your article. A very interesting application for this category is actually pinyin input method. So if you speak Chinese, you are using a bit of pinyin as your input method, you will know what I'm talking about. You're inputting a bit of the English characters and you'll try to get the Chinese characters out of it. So this is the overview of NLP tasks. Of course, there are other tasks like clustering and some unsupervised learning part of the NLP. But for my talk, I will try to focus on all this. And all of that mainly are about supervised learning, meaning that you will need label data as input for all these tasks. So the first one I'm going to talk a bit is about entity recognition. By the way, of all these titles, I will put my GitHub repo here, the link here. So basically, most of the work I present today is actually open source. So if you're interested, you can just go to GitHub and check the work there. So this project is doing entity recognition using IDC and CRF. So CRF is conditional random field. So traditionally, before deep learning, people use only the conditional random field to do the interrecognition. But now with word embedding, with deep learning, we are actually using this iterated dilated convolutional neural network to do that. The reason that we use this dilated, so first, what is dilated convolutional neural network? It basically means that you start from an area, but instead that you cover each one that is adjacent to it, you actually skip one of in between so that you cover a bigger area. And next step, you skip like 4 of it, so you cover even bigger area. So this gap is actually exponentially increasing. The reason we do is that for the traditional convolutional neural network, if you want to cover the whole area, you have to have a very, very deep structure so that it can cover the whole area. And that will cause a lot of overfitting and cause a lot of so you're going to have to use like dropouts or some other techniques to actually overcome all that difficulties. But with IDCAN, as you can see, you can just use 3 layers to already cover such a large area. So this is an example from a computer vision area. So if we're talking about a sentence, it will be a one-dimensional sequence, and this will be very similar to this one, but on one-dimensional. You can see I skip 1, I skip 4, and then I skip 8 here. So skip 2, skip 4, skip 8 here. So this is the way that we do it. So the input of the sentence will be here, and the output of that of this neural network will be here. So I use this structure to do the entity recognition to try to extract the entities from the sentences. And here is a bit of examples here. Sorry, it's a bit small, but it's quite amazing because if you think about it, if you're actually doing this entity recognition with a rule-based system, you're going to have to write a lot of rules. But with the deep learning method, with enough training data, you can actually get a very amazing result here. For example, it says Putin and Trump got a call, and you can see the Putin is here and Trump is also here. But of course, you can see a bit of error here, which he put another character after Trump as part of the name. But you can still see that all the company names, all the person names, all these different kinds of entities can be extracted from this structure instead of writing a lot of rules. So this is very elegant and data-driven. The second example would be to do the relation extraction. So what is relation extraction? You think of that with one sentence, you already have extracted 2 entities. Let's say you have extracted Trump and President Xi, right? Or another character, and you want to find the relationship between them. So that is a relation extraction. So the way we do it is we're using by GRU. So GRU is actually a simplified version of LSTM, and we're using the bidirectional way of that. We are actually also put a lot of the attention there. So both on the character level attention and also on the sentence level attention. But one important thing is that how do we get the training data? If you want to do a relation extraction, you need to have a lot of examples of one sentence, multiple entities, and the relation of it. So how can you do that? The way you do that is what we call the distance supervising. So basically, you try to find some famous people. So if you know Chinese, you probably know this Andrew Baby and Huang Xiaoming, who are both very famous actor and actress, and they're actually husband and wife. So what we do is we try to find all the sentences from the internet that contains Huang Xiaoming and Andrew Baby, and use all those sentences as the example of showing that the relationship is actually husband and wife. So in that way, you can actually crawl a lot of training data and use this network structure to actually train such a model. So this is a bit of the result. As you can see, I try to be a bit naughty here. Try to put a bit of different sentences here to test the algorithm. So this one is like this SC is the first guy A is responsible for the coding, and the second guy is responsible for writing the paper. So what are their relationship? The most probable relationship is cooperation. But you also find like a reporting line here. So probably in the real examples, who are responsible for writing would probably be the professor, and the first one would probably be the student here. And you can see a lot of different example here. So they are all spontaneous examples that is written in a very human way. So imagine that you're doing this relation extraction from a rule-based system. You're gonna have to write a lot of rules to actually achieve this kind of results. But with deep learning, with a bit of training data, you can already get a very nice result here. So with entity recognition and with relation extraction, what can we do? The most obvious one is actually we can construct a knowledge graph out of it. So you can do entity recognition, and the entities will be the nodes. You can do relation extraction, and the relations will be the links. So basically, if you are doing both from articles, the articles can become something like a graph. This is a bit of example that we did, extracting all the names from article and try to build a knowledge graph out of it. There will be a lot of applications based on knowledge graph. For example, some visualizations, explorations. For example, you want to check what's the relationship between Trump and another guy with this huge knowledge graph. You can actually trace or find the shortest path between it. Then you have a lot of graph-based algorithms. For example, how do you calculate that shortest path? It's actually a very difficult problem if you're considering a very large graph. And last but not least, you also have graph database development. There are currently two kinds of graph database. One is relational, and another one is NoSQL. I think the most famous graph database now is actually I don't remember the name, sorry, but yes, Neo4j. It's a commercial one, but it's a lot of people are using it. But of course, you also have a lot of open source graph database out there. So this is knowledge graph, and by the way, knowledge graph can be a very important database to support the chatbot that you are building. So if you're if you're building a chatbot, the chatbot wants to respond something that he wants to extract data from the database. Knowledge graph can be just that database that you're extracting knowledge from. Another example would be natural language understanding. So this is a very good open source project, RASA. And what I did in this repo is actually I tried to extend their very nice natural language understanding work to Chinese language. So the NLU, which I will talk later, mainly contains of entity recognition and intent recognition. So you try to find the who and what that sentence is talking about and what intent it intends to do. So I will cover this later, but basically there are a lot of online services with RESTful API here. Of course, Dialogflow from Google is a very good one. You also have from Microsoft, Facebook, and Baidu, but all of them are actually deployed in the cloud, and you have to call from the cloud. So if you want to deploy such a system in a private environment, you might want to check out RASA. Another example would be to build a pinyin method. So in this project, what I tried is I tried to use the sequence-to-sequence model to actually build a pinyin input method. The structure is like this. You have a lot of batch normalization. You also have highway links here. So this is actually an old structure that Google used for its machine translation, but it's still, we tried it on pinyin input method and it works pretty well. The good thing about this project is that you can actually get unlimited training data because whenever you have a Chinese character, you have packages that can convert it back to the English pinyin there. So our task is convert it back, which is very hard. So you can see that I trained it on some old news article, and I tried it with input the pinyin and try to find the Chinese character, and it works pretty well. And also, if you try to make some mistakes in the pinyin method, it can still it's quite error prone, right? It can still try to detect the error and give you the correct Chinese sentence. So the project repo is still here that you can try to check out. So I've showed you a lot of different neural network structures, right? The IDCNN, the BiGRU with attention layers, the sequence-to-sequence models, all these different structures. So which neural network should I actually use if you have an NLP tasks that you want to solve? So for computer vision, what you have is actually a lot of pre-trained deep learning models like VGG or Exception. So what they are is basically they're training on data sets like ImageNet, and they get a very, very nice base model. It's quite large, but it's a very good base model. So if you have a new computer vision task, you can basically just add a new last layer there and just fine tune that model. You can phrase all these pre-trained models, but just fine tune the last layer for your certain task. So this is already quite popular in computer vision. For NLP, we actually only had some pre-trained word embeddings. So with word-to-vec for fast tags, can we actually have pre-trained deep learning models? The answer is actually yes. So I think 2 years ago, we have this BERT, which is bidirectional encoder representations from transformers. And of course, you also have some other structures followed by this one, like GPT-2 and all that. It's very large. It has like 24 transformer blocks, 1024 hidden layers, and you actually have 340 million parameters. So it's huge. It's a huge model. But the good thing is that it's exactly like computer vision. You can now build NLP models, just use this BERT model as your base model. And once this BERT was published, it actually won 11 language tasks, including Glue, Multi-NLI, and Squad. So I show you a ranking of the Squad here. So this is right after several months after BERT was introduced. Actually, I think BERT was introduced by Google, but you see that already after several months, Google is only number 5 here. And you can see, so this is a ranking of a competition there, and you can see a lot of different companies, they're actually ranking much higher than Google. So I think it's a tradition that the Chinese companies are really good at standing the shoulders of the giants, right? So the giant is here after he introduced BERT, then the Chinese companies, we can actually quite quickly develop all these models based on it and actually perform even better than the original model. And what's more interesting, you can see that Pingdan here. So Pingdan is actually an insurance company, but it's actually have a position here in the technology competition there. Yep. So that's part one. I hope I gave you a quick introduction of what NLP is and what kind of projects we're working on. The part two would be for chatbot. So the first thing I want to ask, so when you try to build a chatbot, the first thing you have to ask yourself is, do you really need to build a chatbot? If your context, by the way, the chatbot I mentioned here are all task-oriented chatbot. It's not chit-chat. So if you're looking for chit-chat solutions, it's a totally different thing. And you can probably build a nice chit-chat chatbot just with sequence-to-sequence model. But here, what we're talking about is task-oriented chatbot, where you really want to solve a problem for your customer. So if your context is that you have an interaction with a single target and the steps and logic are quite clear, then don't use a chatbot. I show an example here. This is from McDonald's in Hong Kong. You probably also have that in US or in Singapore, where you just go to McDonald's and they have this nice screen. You can just click and get what you want directly from that screen. So don't use the chatbot for that use case, right? Because it's so clear, the steps are so clear. You don't really need a chatbot for that. But what chatbots is really good for, first, it's good for customer service in the vertical domain. You really need to have some domain knowledge to actually solve the customer needs. Second, if you have a lot of similar questions and inquiries, then the chatbot can actually learn from the questions and give you a good answer. And the targets needs to be clear or at least semi-clear, but the customer may need a bit of guidance there. But that will be where the chatbots performs. What's the advantage of a chatbot is actually it can automatically get the user profile, so it knows what you need. It can actually give you the personalized recommendation. It's instant read from vast relevant knowledge base, so it can actually have a very knowledgeable or a very large knowledge base in the backend to support its answers, and it can give you the personalized answers through multi-round dialogue. So suppose you don't really ask your question right in the first round, it will try to lead you to make you clear what your questions really is, and then give you the right answer here. So chatbot is actually not a new thing. We already had chatbot for a very long time. The traditional chatbot is actually mainly built by two ways. The first method is you just build a chatbot with a set of rules. So I'm actually putting the example here. It's developed with the AIML language, which is a rule-based language specifically designed for chatbot. So I put the demo, the repo also here. So if you're using a set of rules to actually create this chatbot, it will give you very high accuracy, meaning that when you get the question, if you know, you really know. But if you don't know a lot of the questions, because the customer may ask a question in a lot of ways. So if you don't know, you don't know, and the recall will be very low. There will be hundreds of expressions from the user just for one single intention. So you can imagine that it's really difficult to write all the rules that cover all that intention. So, and also if, with the internet, a lot of new expressions are coming out, and it is really difficult to maintain such a rule-based system. Another way is actually to use semantic similarity. So you always try to match the question from your user to a database of all the questions. This method, you will need a very large quantity of data, and the accuracy is actually quite low. So what we do now is actually using a bit of machine learning to actually build this chatbot. From my point of view, the current mainstream chatbots architecture are basically composed of these three different modules. First is the natural language understanding. Remember, I talked about Rasa NLU. That's what it solves this part of the problem. And the second one will be dialogue management, which try to manage your dialogue flow, try to understand your question in multiple rounds, and try to extract that information from the database. And the third one, the last one, would be natural language generation. So we know your question, we get the correct ingredients to compose of this answer, and we will try to generate that results in a natural language way. So that's the NLG does. So first, the NLU. So I show here actually a basic structure of normally what an NLU does. So basically, you have to do a bit of pre-processing of the questions, the user input, and then you have to do two tasks. One is you have to figure out what the intent your user is going is asking. So that's a text classification problem. And then you need to figure out what kind of entities are within that question. So that's a sequential labeling problem, or that's an entity extraction problem. Traditionally, you do a lot of that. This is bunch of stuff is what I talked about, the linguistic features. So traditionally, you use a lot of manually made linguistic features, and you go through some traditional machine learning algorithms like logistic regression or supporting vector machine, and you achieve this too. But with the development of deep learning, you can also do it with word embedding and with some deep learning structure. But very importantly, that for most of the NLU system, you also have a rule-based system here, which supports the machine learning part. So if the machine learning part finds that the results, the confidence is really low, so it will basically revert back to the rule-based system, and rule-based system will try to find some keywords and try to match some rules to actually give you that intent and entity. So I give some examples here. So basically, this is, I want to find a shop for noodles. So if you input that, the NLU will give you, okay, there is an entity here which is noodle. So you are trying to find noodles. And the intent is actually you're trying to find a restaurant here. So this is an example of a Chinese NLU here. Of course, you need to do a bit of system integration. So with the NLU, you have to put it in the service layer. But under the service layer, you also have a storage layer where you have all that user input data, you have the model, you have the training data, and sometimes you have a bit of the index in there. But upon the service layer, you then have a nice interface layer where you can do system configuration monitoring, or you can have a bit of user interaction. And it will cover, you will have a UI for like API monitoring, model management, and data management. So later I will show you a demo of the tools that we built, which is basically built with this infrastructure here. And of course, the service layer can give API to the interface layer, but also can expose its API to some other services there. The next module would be dialog manager, so which is here. So the dialog manager basically do multi-round dialog management, and it will do knowledge base query from the knowledge base to get the correct answer, and it will try to maintain the current dialog status. So imagine you're asking a question, but you don't really ask it, you don't really provide all the information to the bot, to the chatbot yet. So the chatbot will try to lead you to get to give the bot all the information that the bot needs. Example is here, the user asks, the kid is sick, what should I do? So then we first go to NLU entity recognition, so it's sickness. Then we do entity extraction, so it's a child here. The dialog manager finds out, okay, there's no age, no symptom, and no gender for the kid. So then we go to the natural language generation and generate this question. So how old is your child, boy or girl? The user will answer, okay, 6 months boy. So the entity recognition finds it's 0.5 years old, it's a male, but the dialog manager finds, okay, still no symptom here. So again, natural language generation, what symptom does he have? He's having a fever, the user answered. So the entity recognition will find fever. And now we have all the information, right? And then the dialog manager will do a query on the knowledge base, define and finish the task. And then it will show, okay, please call Dr. Chai at a phone number. So this is basically what dialog manager does, and also give you a bit of sense what natural language generation here does. As here, you can see the main tasks of dialog manager. So it will do status management. So it will try to manage the current dialog status, user history, bot history, and possible answers from the knowledge graph, from the knowledge base. It will maintain a multi-round dialog. So it's a user's intent clear, it's the information enough, and it will try to query in a guided conversation. It will also execute, so it will try to put NLU result into database query, and it will put NLU results into a task execution. Whether you're buying from a shopping from online shopping, so it will add to shopping cart, or it will call someone's number. And of course, it will have multiple ways of implement this dialog manager system. But this is kind of, there's no standard work regarding to this one. So some people do it in a rule-based way. Some people do it as a supervised learning part, as a sequence labeling problem, because you have a dialog sequence there. And if you have enough training data, you can actually consider it just as a sequence labeling problem. And you can use deep learning and all that to actually train the dialog manager model. And also some people are actually using deep reinforcement learning to train the dialog manager. So you have some user simulator that tries to answer the question from the bot, and the both parties will actually interact with each other and try to maintain a reinforcement learning infrastructure to actually train such kind of a model. The last one is natural language generation. So this one is also it's very important, but I won't cover it too much. But there are basically two ways. The first one is templates. So you manually generate template sentences with some entity slots. It's basically a template failing problem. Another way of doing NLG would be data-driven. So you have a lot of training data. You can actually train a sequence-to-sequence model to generate that language. But it's now here, it's actually trying to learn that templates with the entity slots. So you try to use NLG to generate that template, but you just fill in the entity slots from the knowledge base. A lot of the system currently are actually using a hybrid way of both two. But the most recent or advanced research part is actually how can we, instead of having all that different modules, can we build an end-to-end chatbot of the whole modules just based on deep learning? So there are actually research works on that. So for NLU, DM, and NLG, each module can actually be DL-based. So this is example here. Sorry, I didn't put the link to the paper here, but if you are interested, you can definitely check out from the internet. And there are also some other works for memory network, which is instead of having a separate knowledge base or separate database, we're trying to embed the whole knowledge, the whole knowledge just into that model, just into the model parameters. So that's also quite a frontier research there. But What I see is I still don't find a lot of real applications using this kind of techniques. Mainly, it's still from academic research point of view. So yeah, I hope it just gave you quite a quick overview on the chatbots. And here I want to show you a tool that we built. It's a full pipeline UI for building a Chinese NLU system. We call it ChatStack. So I will quickly go through the slides and show you the demo. So ChatStack is a full pipeline UI for building a Chinese NLU system. You can define your intents and entities. You can label the training data. You can train the NLU models. You can manage the models, test and deploy NLU MPIs, and even do the dialog management without writing any code. So you don't have to write any code. Just use our tools with a nice UI. You can do all this stuff. And it is specific designed for Chinese language. Basically, for customization for Chinese language, you need to do tokenization because for Chinese, all the characters are stick together. It's not like English where you have the blanks in between the English words. For Chinese, it's all stick together. So you have to do a bit of Chinese tokenization first before you can run all the different algorithms. We have a domain dictionary. We have Chinese word embeddings. And we use all that customization algorithms for text classification and sequence labeling, as I just mentioned before for the NLU task. And we have an intuitive UI for data labeling. We also have a UI for user model and API management. So if you allow me, I can quickly give you a demo here. So this is the UI, the input part. So if I log in, as you can see, we have, sorry, it's all in Chinese, but if you read Chinese, you will find it quite easy to understand. So we have entity recognition here. So you have different intents that you can input here. You have entity recognition here, where you can define your entity here. So it's always UI that you can input and save. You can see all your training data here. So this is the training data that you have to input here. And you can actually also try to highlight the entities and try to label its intents there. We also have a production log. So you can actually have all the historical API calls, so what the users are actually calling your models. And you can also have the model management here. So basically, those are all the historical models that you built. You can see who built it, when you built it, and you can actually choose which one is a testing model and which one is a production model. Testing model is what you just testing here with this UI, and production model will be the model that you use for exposing the API for productions, for production systems. And of course, you will also have account management. So we give different access to different tasks. So if this guy is allowed to train an NLU, if this guy is allowed to modify the intent and entity, if this guy is allowed to change the different versions of NLU models or change the training data or look at the production log or even reset your password. So all these different access rights, we put it in a nice UI where you can modify. So yeah, that's basically all my presentation. Again, I put on this cake. I hope you understand why I put a cake here, because the NLP is a very I would say a not solved problem. It's not like computer vision where you have already solved a lot of problems. For NLP, it's still, I would say, in a very initial stage. But you do see a lot of different algorithms that you can put together. And Chatbot is a great example of using all that different technologies to build a application. And hope that you find my presentation tasteful, just like the cake here. Again, if you're interested, you can reach out to me either by email, GitHub, LinkedIn, or you can check out my blog here. That's all from my presentation. Thank you.
Hey, Guan, thanks for the insights that you've provided us today in that three-part presentation. I think that was a very awesome presentation. If there's anyone who has any questions, we have one question. Okay, so let me just repeat this question for the audience. So from Songhan, could you share a bit more on the challenges of working with Chinese language for NLP problems as compared to English?
Yep. So very obviously, if you look into the academic research area, all that most of the research on NLP are based on English language. The training data, the academic research data and algorithms are all designed specifically towards the English language because it's a global language. So the main challenge for working for Chinese language is to find such kind of good training data or good data that you can at least test on your algorithms. So that's a main challenge. There are also a bit of technical challenges, like I said, for example, the tokenization of the Chinese the Chinese sentences, because all the characters stick together instead of like English here, you have blanks in between them. So that's an example of the technical challenges that we have. But one way we solve it is we're trying to, instead of use word embedding, we're using character embedding. So each of the character of the Chinese character is actually a unit for that embedding vector. And it turns out it actually works pretty well. So you don't actually need to do a tokenization. You don't need to do tokenization before you really run your Chinese language algorithms. Yep.
Are there any other questions within the audience? So I do have one question.
Yep.
Can you hear me?
Yes.
Okay. I do have one question of curiosity, which is, so it seems like you are very advanced, very experienced in this topic, and you being also a GD as well. So I think maybe this is also sort of like carrying on our last speaker's part of what he introduced. Are there any recommendations you would give towards, let's say, beginners in the audience on how they can start with picking up ML?
So if you're just talking about machine learning, definitely there are a lot of free training courses there. So I personally, when I started my career of data scientist, I personally learned most of the knowledge just from Coursera. You have excellent courses from Andrew Wu, from University of Washington, from a lot of experts in machine learning just on Coursera. So if you are just a beginner, you should definitely check out Coursera or some other platforms. Most of the content are actually free for you to learn. But once you've gained a bit of concepts that you understand what machine learning is, I strongly recommend you to go to GitHub and check out the other projects, because if you don't do hands-on, then you are not really in this area. You're not really doing data science or machine learning. So I highly recommend you to go out there to check out the different repos, different projects from others on GitHub, and try to read their codes or even modify a bit of their codes and run your version of that and check the results. That's my recommendation. Yep.
Nice, I agree with that. Yeah, hands-on learning is always definitely the best. I think we have one more question, so let's take one more question over here, which is from Saurabh. What are resources to start with Chatbot using GCP along with ML that you would recommend?
Yep. So if you're using talking about Google Cloud, you should definitely check out Dialogflow. Dialogflow is a product or a service provided by Google. It's actually quite similar to what I just showed you in my demo there. But if you're, like I said, if you want to try some algorithms or try some NLP projects by your own, you can just apply for a Google Virtual Machine there and try to code from scratch. The Google Cloud have very nice GPU support where you can train deep learning models. And I think if you register as a new user, they even give you like a bit of free credits for you to start. But just a word of warning, if you try to deploy a TPU environment, it will cost a lot. I tried to deploy a TPU pod, and it basically used up all my credits just in the weekend. But still, it's a very nice platform that you can try there. Yep.
Nice. Hey, thanks again, Guan, for your insightful talk as well as your answers that you've provided for our audiences as well. Thanks again.
Thank you.
Yeah. Okay, so let's move on to our next speaker. So, okay. So last but not least, we have one more speaker for today. So our last speaker for today's event is Archana, a graduate research student at NUS, where she researched on how to apply deep learning techniques to smart grids. Okay. As part of her research, She uses Google frameworks like TensorFlow and TF-Lite, tools like Colab and Google, hardware like TPU and HTPU boards. She's also a course instructor for university's AI for Edge IoT Nano degree, where she can teach you how you can choose the right hardware for deploying your models. Okay, and she has also been an active member of this community, doing other presentations, speaking at other events as well. So today we're going to welcome her with a topic which is quantizing neural networks using TensorFlow's model optimization toolkit. So Archana, take it away.
Hi everyone, I hope you can hear me. Very nice to meet you, and I'm so glad that you joined me here today. So today I'll be actually speaking about quantization of models using TensorFlow's model optimization toolkit. Yeah, so a little bit about me. I know that a little bit of introduction has already been given. So just to like recap on that, I'm currently a graduate student here at National University of Singapore, and I do masters by research, and my research is on applying deep learning techniques to smart grids. And previously, I worked as a deep learning research engineer at Sama Technologies for 2 years. I'm also instructor at Udacity. So for the nano degree program of Intel Edge AI for IoT developers. And for this, I thought the course for choosing the right hardware for the edge. If any of you are taking the course and would like to reach out to me, feel free to do so. And so, what exactly will you be learning today? So, firstly, I'll go a little bit into edge computing. I'll talk about the need for quantization from this. Then I'll talk about how exactly does in-date quantization work, and then go into explaining quantization in maybe simple words. And lastly, I'll also talk about the TensorFlow model optimization toolkit. Now, this actually has components of post-training quantization techniques. It has quantization aware training. So all of this together, one thing that we have to realize is that this field has a lot of potential, and something like quantization aware training, the newer part of the package, came out like last month. So it has a huge potential for improvement, and has a huge potential to actually make an impact. So do stay tuned and listen. Maybe if it might interest you, you might end up actually doing something on it. So edge computing. Now, coming into what exactly edge computing is. So there's an increase in IoT device all around you, taking right from your smart, washing machines to your smart TVs to your mobile phones to your transportations. Everything is going smart. And what is happening is that you wouldn't necessarily want these devices to be talking to a cloud or a server all the time. You would want these edge devices to have their own data centers. This computing, which involves the edge devices data center, is actually called edge computing. And the various applications of it. Firstly, we have stuff like security cameras. Imagine you have a security camera installed right outside your home, and it's sort of checking uh, you know, the people who are passing back and like sort of passing in front of it, and you're finding out if some one of them is a burglar. Would you want information which is quite private of people's faces to be going to the server all the time? Probably not. You would like to keep it private and secure right at the edge. So this is something that is offered by edge computing. Another very interesting application is self-driving cars. So imagine you have a self-driving car passing through a tunnel, and it suddenly has to apply brakes. Now, within that few seconds or millisecond, would you really want the self-driving car to do its computation for, pressing the brakes and sending it to a server very far away? I mean, that very second could be a case of life and death. So, hence, we need edge computing for devices and also for use cases like this. So, what are the advantages of edge computing now that I've talked about the use case? Firstly, is the reduced latency, as seen by the self-driving car case. Then we have reduced internet bandwidth. Imagine you have a edge device kept in a forest somewhere. You do not need internet connection for it to run models. You could have it completely independent of the internet. And then there is increased security, as seen by the case of the smart camera. You have all your computations and all your information extraction done right at the edge. That helps in security. And lastly, taking all of this together, your reduction in dependence of cloud services actually decreases. So this comes towards the need for quantization. Now, if we take our neural networks, there are several power constraints with neural networks. So traditionally, neural networks were built to actually, perform a massive amount of computational power. This included CPU or GPUs. So CPU or GPUs ideally take about 140 to 150 watts of TDP, which is the thermal design power. Whereas if you take a small device like Raspberry Pi, that might only take 1.5 watts and composed of floating point values. So this is one of the very important aspects. Neural networks were traditionally trained to preserve accuracy and speed. And to do so, the only way to do that was to have floating point values such that you could do proper MAC operations. And this is something very important to quantization because this is exactly what we are trying to target. Then you have memory constraints. So most laptops or your PCs come at least with 4 GB of RAM, whereas Raspberry Pi only comes with 1 GB of RAM. So you have to make sure you have a model such that it can run on such memory constraints. At the end, you want inference efficiency. What I mean by that is we need a model that takes much less time to do inference than our normal models. This brings us to the actual definition of quantization. So the definition of quantization is actually picked up from mathematics and signal processing. What it states is the fact that it's a mapping of input values to a large set of output values in a smaller set with a finite number of elements. Don't worry, the definition gets better for edge computing. In edge computing, it's basically the process of reducing your floating point 32-bit values to lower precision values like int8 while preserving the information in the neural networks. And I think this is a very important aspect because you want to make sure that you have, even while you're getting your model, reducing the model size, you want to make sure that it has all the information preserved. So how exactly do you go about doing that? So, firstly, let us just take a very simple example of how int8 quantization actually works. So, let us take a neural network which has values from minus 10.00 to 30.00. This is a floating point value. Now, to convert it to int8, that is from 14.32 bit to int8, you have to define its max and minimum values. Doing int8 quantization, you will define the minimum value to be 0 and you'll define the maximum to be 255. Why do we do 255 is, if you remember your high school math or college math a bit, 2 to the power 8 is 256. So 0 to 255 values is 256. And all the values are actually scaled in between the range of 0 to 255. So what happens when we actually want to represent the value 10.00? So this is a little bit of math, but trust me, it's all linear algebra. And it'll be quite quick. So firstly, we define the old range, which is the old maximum minus old minimum. Then we define the new range, which is also new maximum minus new minimum. And then the new value, it's a little tricky, is old value minus old minimum into new range by old range plus new minimum. Don't worry, let us just try it for the value of 10.00. So the old range is equal to 30 minus of minus 10, which is equal to 40. The new range is 255 minus 0, since 255 was our new range maximum value and this is our least value. And the new value is our old value, which is 10 minus our old minimum, which is minus of minus 10, into the new range, which is 255, divided by the old range, which is 40, plus 0, since that is our new minimum. So what is the value we actually get? We get 127.5, which rounds out to be 128. So as you can see in this table right in the middle, 0 then gets mapped to minus 10. 255 gets mapped to 30 because that's our largest value. And 128 gets mapped to 10. So this is how int8 quantization works at its very low level. Now, how exactly, like I know I've told a lot of math, so I just want to wrap up quantization in like really simple words. So taking this from Pete Warden's blog, what he says is, like, for example, if you're going out and all you care about is the fact that whether it's raining or not, you don't care if it's raining heavily or if it's raining just lightly. So this is exactly how it works with neural network predictions. You often don't require floating point calculations of 32-bit or 64-bit or 16-bit precisions. with some amount of effort, you can actually use 8-bit integers to perform neural network inference and still maintain the appropriate level of accuracy. So this is what the TensorFlow model optimization toolkit goes behind. So basically, the TensorFlow model optimization toolkit consists of like tools for quantization aware training, model pruning. So model pruning is another feature, but it's something that I won't be covering. But there are enough resources about model pruning if you want to know. And then there is post-training quantization, which I'll also cover. So what you do is you choose layers that you actually want to quantize in your model. Like for example, you have a very big CNN model. So you choose the layers you want to quantize. You can either quantize all layers or you can quantize some specific layers. What I mean by quantization here is you're converting the huge floating point 32-bit value to a smaller int8 value, lower precision. And then what happens is you're making sure that it contains a mixture of fixed and floating point values. So some of the layers might be mapped to fixed point math, whereas some of the layers might be mapped to floating point math. So believe it or not, the most sensitive ones with higher precision, that is, say 32 or 62-bit, have little or little to no final accuracy loss for the task. Yet just speeding that, converting that helps us to speed up the floating point execution. Hence, it's very necessary that we end up converting those values. And one interesting thing about the TensorFlow model optimization toolkit is the hybrid kernels. What the hybrid kernel provides is that it gives you parameters to actually reconvert to higher precision values. And I'll talk about it a bit later, but all you need to know is that even when you sort of convert it to lower precision rate, you need to get it back to floating point values to be actually able to execute inference. Now, like what we discussed right now was, for example, if your weight values are in floating point 32-bit values in the range of, let us say usually in the range of -1 to 1, then your int values are in range of -127 to 127. It could be 0 to 255 as I showed before, but these are unsigned and signed integers, so they are a bit different. But the range can be any. All it does is it has 256 numbers. So basically, you have two types of quantization. One is you have weight quantization, and the second one is that you have weight and activation function quantization. So let us just recap about what we know about neural networks. We have an input, and what we do is, so while training, we have two types of passes. We have one, which is a forward pass, which helps us initialize all the weights and get the output. Now, from the output, we estimate the loss, and then we do a backward pass where we update our weights. Now, similar to that, you also have a forward pass for inference, and this is exactly what TensorFlow's model optimization toolkit targets. So out here, we have something called post-training quantization. So post-training quantization, the weights in the forward pass, that is during inference. I mean here, your 32 bits are converted into 8 bits. Now, if your 32-bit values are converted into 8-bit values, the first thing that comes to your mind is, I'm going to lose out on precision. And that isn't right, because you're doing all the calculations inside your neural network on precision values. So if I lose out on precision, won't that affect my neural network? You're absolutely right. So we actually do the calculation and then we upconvert it during inference. But this also leads into some sort of precision problem. For example, you have the value 0.2345678. This is quite a huge value, but this is just for reference. So if you were to convert this into floating after this conversion, it would end up being 0.235, which would still be floating point values, but would be very different from what you need. So what happens with this is you end up losing out on precision in weights, which actually leads to a drop in accuracy, which you do not want. I mean, as machine learning enthusiasts and machine learning engineers, we constantly work on projects or with clients who would want to get a specific amount of accuracy. And, a drop in accuracy is something that most people can't tolerate. So how do you end up actually running models on the edge while maintaining the level of accuracy? Another thing that post-training integer quantization actually gives you is lately they have gotten into weight and activation of the model. So previously, as I showed, the weight values could be changed, but they have actually gotten into activation values as well. And this is sort of like it differs from the hybrid operation, since they also focus on weights, and they also take in computation values, and it enables user to take a already trained floating point model and to fully quantize it into 8-bit. So that's something very interesting, because you're able to take an entire model and being able to quantize it to 8-bit. And so what this offers is, if you do remember, I talked about it before, you can choose the layers which needs to be run on a particular, which needs to be quantized. Another advantage of this is that you can choose the layers, or you can choose some parts of the model to be run, which have to be specifically run for floating point to be run on the CPU, while other parts which do not require floating point operations can be run on specialized hardware like the HTPU. But at the end of the day, you have an accuracy drop, and that is something that you cannot tolerate. So Google came up with quantization aware training. So quantization aware training is mimicking real world quantization at inference. So what it actually does is it enables you to sort of train your model while keeping the performance and size benefits of quantization and retaining as close as possible to the original accuracy. Later on, we'll actually run it. I'll show you a short demo, and we'll see the results. But yeah, I'll show it to you on real time. So what are the problems with quantization that we ideally have? We have the process is that we're going from higher precision value to lower precision value. So it's lossy in nature. And you're rounding off values. So for example, you had values of 0.23456. At the end of the day, it got rounded off to 0.235. And that is sort of, you're introducing errors like rounding errors. And then you also have loss. So there are various types of losses which are introduced. So like you have firstly an information loss. So previously you had more information, but after quantizing, now you have information which is coarse in nature. And then you have computational loss. At the end of the day, all neural network is a bunch of MAC operations. So when you have loss and you multiply and accumulate it, it's obviously going to increase. So the computational loss also increases. And you have rescaling loss, because obviously you're converting it from 32-bit to 8-bit. So these are the types of losses that come up. So what exactly is QAT trying to, what is the core idea behind QAT? So with QAT, you're sort of trying to introduce errors that happen during the quantized inference into the training process, essentially emulating the process, and that actually helps the trainer learn around the error to get an accurate model. So what I mean by that is you're sort of trying to learn the loss from before, and thereby not facing the accuracy drop which you did before. And out here is a short way in which they do it. You take the weights and then you quantize it. The way that you quantize it is you make it into 8-bit, and then you up convert it to 32-bit again. Then you run it through a convolution operation and give it a small bias, and then you run it through an activation function of ReLU 6. So through this process, you're trying to make sure that your accuracy remains as close to as possible from the actual the actual test accuracy, and that it doesn't drop when you actually reduce the model size. And let us see the results that actually Google got. So MobileNet model actually for floating point value, this is without quantization, you get it as 71.03%. But when you do not do quantization aware training, and you just do post training quantized model, you actually get a drop in accuracy. But after doing quantization aware training, there's actually an increase. So here you can see there's like a 2% drop, and with quantization aware training, you're getting almost equivalent and a little more actually. So we decided to sort of run a similar model, and I would like to show the demo for that. So yeah, we ran a similar model for identifying the different types of weeds in plants. And this is a classification problem. And this had like 9 classes. And it was part of TensorFlow dataset. So if you see here, I just have imported it directly from tfds.load. So yeah, so first we ran the model normally. That is without any quantization, just doing normal using Keras. So this is the testing accuracy we got.
And then we did quantize aware training. So this, during this step, what happens is that we are actually making sure all the operations, if you remember the con operation, like that, we are making sure all the operations are quantized in nature, but the weights aren't. So when that happens, we are actually getting an 89.72 accuracy. Now we go ahead and we actually quantize the weights too. If you want to look at the summary of the previous model, you can do that as well. You can see all the operation are quantized. So I ended up quantizing the entire model. Like you can still choose layers you want to quantize, but in here I've quantized the entire model. And then what you do is you run the accuracy for, then you run it via post-training quantization. And when you run the quantized aware model, you get an accuracy of 63.22%. Now, the same model, without running it through QAT, when I run it through post-training quantization, I get the accuracy as 45.23, which is, I get almost a 20% drop, which clearly means that QAT is quite useful because it's able to learn the losses and thus able to sort of retain the accuracy, or at least give a boost in accuracy. And then this is something we tried, where we try to understand the different model sizes. I think this is very important because, you know, as I told you, a Raspberry Pi might only end up having 1 GB, and you don't want to consume the entire thing for running your model. You want some part to maybe take up for sensor computation. So how do you end up doing that? So the main model here took up about 12 MB. The normal TF Lite model without quantization took 9.2 MB, and 2.5 MB was taken up by the quantized model. So you can see a drastic decrease in the amount of space that this model might take. And yes, and then you can optimize the model for different different schemes. Firstly, you can optimize it for size. So when you optimize it for size, we get a little bit of an increase in accuracy. Another thing you will notice is when you optimize it for latency. Latency is basically the time it takes. So ideally the time should decrease, which it did, not by much. So we have 0.48 previously, 0.048, and on this we have around 0.0478. There was a slight decrease in time taken, which is good enough, because if you like try to increase the model, you can see drastic changes too. And yeah, that is it. I know the results are not very promising, but we took up a very new field, and I think there's a lot of room for improvement, even on the model side and even on the packages such. So I believe that will happen for sure. And what are the different resources to follow? You can actually follow some blogs by Pete Warden on quantization. There are talks by Pete Warden or TinyML talks, which are really good. And there are TensorFlow blogs on optimization toolkit. I've also linked it here. And so Shaya Paul has actually written a blog on this, which is called A Tale of Quantization. And you also have the TensorFlow Dev Summit 2020 video, which actually talks about QAT. And if you're someone who loves to learn from videos, this is like the ideal resource for you. And this brings me to the end of my talk. I hope you enjoyed it. And I would love to have your feedback. I know this is sort of a new area, so if I have to give a talk about this again or improve it, I would love to have your feedback on how to do that. So this is a small QR code that you can fill in order to give your feedback. And at the end of the feedback form, you'll get all the resources that I have stated and the link to my slides. And the responses will be completely anonymous. You don't have to worry. And I also want to give it a shout out or a thanks to Soham. So Soham really helped me in making those notebooks because I was facing a lot of errors, and thank you for helping me. And yeah, stay at home, stay safe, and please do take care of your mental health. Thank you. Thank you so much for listening.
Thanks, Archana, for sharing with us regards to your insights today. Can I request that you go back to your last slide, so for the QR code? So I think while I think around this time, let's so for the audience as well, if you have any question or if you want to also scan that QR code, see the content, I think now would be a best time to do so. And yeah, if there's any questions, please ask them in the chat. Okay, okay, maybe there's no questions. But her contact details are there. So if you would like to reach out to her to ask her questions directly, you can do that. So once again, thank you very much for sharing with us your insights today.
Thank you. Thank you so much.
Okay, so share my screen. So I think earlier on we had a portion on our first speaker who was not managed, didn't manage to answer the questions. So let me check very quickly to see if he's able to come online. Okay, so while we're waiting for him, let me just go through some of our details that we want to share to you with you. So in addition to all the awesome talks or content presentations that were shared today, we're also looking for all of you prospective speakers out there who will be able to conduct these sessions and talks with us as well. If you have any interesting topics, if there's any innovative stuff that you have been doing in your workplace and you would like to share with the community, do drop by this link over here and share with us. First-time speakers are definitely very welcome. Share with us your topics, your profile. We'll look into it. And yeah, we have Amir who's going to be coming online shortly. Okay, so I'm just going to put up the question again for Amir to answer.
Okay. Do you hear me?
Yes, we can hear you.
Okay. The question is, what do you think will be the next frontier of phase to harness ML? That is the question. Yeah. I think it's of it to harness ML will be gaming, for example, with augmented reality. With is it possible to to explore the agriculture to improve or to increase the production of for food in the world, uh, so to give to people a good food, a good fruit, a good area to to give the good plants for medicine. I want to I want I think that the gaming and the agriculture is the next frontier to harness ML.
I see. So agriculture and gaming, I think those are definitely two fields that hasn't really been tapped in terms of ML yet. So I think it'll be quite exciting to see what happens in the maybe next few years, next decade on these current industries. So yeah, once again, thank you very much for joining
Yeah.
us and being able to answer this question on our live stream.
Thank you.
Thank you.
Thank you.
Okay. So let's go back to the conclusion for today's event. So okay, I'm just gonna plug this again. If you're interested in looking to talk, share, or do one of the talks or presentations at one of our events, do check this out and provide with us your profiles as well as the topics that you're interested in. Just to emphasize, first-time speakers are definitely welcome. Okay. And in conclusion to today's event, we also would like to ask for your feedback. There might be some things that might have went well. If you have any feedback on things that you feel can be improved on, let us know over here. And with that, we have come to the end of today's event. So once again, thank you very much for our speakers who have been graceful enough to kindly attend our session today to share with us their knowledge, as well as to all of you, within the audience for spending your Saturday afternoon from 4 p.m. until now, listening to our speakers and sharing your concerns and the questions that were asked, to get the community to learn more about these topics. Okay, so thank you all for attending today, and we'll see you in our next event.